Unit 7, Day 2, given distance locus theorems. There are only two we'll talk about today. But before I get to that, let's do this warm-up. It says a treasure is buried equidistant from two trees. Sketch and describe the locus of points that represent where the treasure could be buried. Now, when it comes to locus, it's very helpful if you guys think of it as looking down from a hot air balloon or a drone or something like that. So looking down on the ground from up above. Two trees would actually represent 2 points. I'll label it T1 and T2. So if someone tells you there's a treasure buried, but it's equidistant from both of those trees, it could be anywhere on this path. Sketch and describe. Well, we just sketched. The description would be the perpendicular bisector of the segment T1, T2, but you don't have to worry about writing that out. All right, our two theorems for today. They're called given distance locus theorems because they're not going to say equidistant. They have to give you a specific number. The first one is the set of points D units from point P. So if I were to tell you to go out in the field, and here's a stake, and I give you a rope that's 10 feet long, I say you can run anywhere you want as long as you're attached to that rope. Where are you going to run? It's going to be a circle. It doesn't have to be perfect. You don't have to use a compass, but just try and sketch a circle as best you can. The center is going to be point P, and that distance D is going to be what you call the radius. That's D. Now, how do we describe this? We say a circle with center P and radius D. And D would be a number. They'll say 3 units away from this tree. And then the last one, the set of points D units from a line. So this line right here might represent a stream, a river, and the directions are you have to always be 20 feet away from the stream at all times. What would that look like? It would look like these two paths here. You could be D units away up above, or you could be D units away on the other side. How do we describe this? Two parallel lines, each D units from the given line. So everything we do in this unit will involve the 5 theorems, the 2 we just talked about here, and then the 3 from the previous lesson. Okay, let's look at some examples. Example 1, sketch and describe the locus of points 4 centimeters from a given point. Well, that's obviously going to be the first one up above. Here's a given point. It doesn't say what the name is. You can call it point P if you want. The locus of points 4 units away from a point is going to be a circle. And the radius of that circle is 4 centimeters. There's the sketch. To describe it, you would say a circle with center P and radius equal to 4 centimeters. Example 2, a dog walks so that she is always 5 feet from a fence. Sketch and describe all possible paths she can walk. So again, visualize you're looking down from up above. A fence would just be a line. As you look down on a fence, it looks like a line. And a dog walks so that she is always 5 feet. So you could walk 5 feet on this side of the fence. Indicate that distance there is 5 feet. Or you could walk 5 feet on this side of the fence. And it doesn't matter. You could draw this vertically, horizontally, at a slight angle. As long as all 3 of those lines are parallel, it doesn't matter how you draw it. If you visualize it up and down, that's fine. So now we have to describe. Here's the description. 2 parallel lines, each 5 feet from the fence. In the next example, we are going to incorporate our coordinate geometry, talking about equations of lines, points. Example 3 says, graph and state the equation or equations of the locus of points 3 units from x equals 1. So the first thing I want to do is sketch that line x equals 1. It's going to cross the x-axis at 1. Draw it in as a solid line. There you go. So now if I give you a line and I want the locus of points 3 units away, it will be 2 parallel lines. It's just like the example up above, but now we're on a coordinate plane. So you count 3 blocks to the right and use a dashed line or dotted line, sketching that vertical line. From your initial line, the blue one in this example, 3 blocks to the left, sketch another line. Now I need to state the equations, right? When I give you a coordinate plane, you don't have to describe it, but you have to state the equations. Both of these will be x equals lines. You just have to figure out what the x value is. This one here is x equals -2. So you can draw it over here, write the equation in the diagram, or over on the left. This one from the origin is 1, 2, 3, 4, x equals 4. Example 4, graph and describe the locus of points 4 units from the point -2, 1. So in every one of these, you'll be given something, a point, a line, 2 lines. In this case, we're given a point, -2, 1. So let's plot that. It doesn't have a label, but if you want to call it point P, that's fine. Or you can just leave it a point. So now, if I want to be 4 units away from a point that is a circle. Circles are a little bit more challenging to draw, so here's what I recommend. If that's the center of the circle and the radius is 4, go 4 blocks to the right and put a point. Go up 4 blocks, put a point. Left 4 blocks, put a point. And then down 4 blocks and put a point. Don't draw in a diamond. Try and make it the best circle you can. Doesn't have to be perfect, but obviously you need to go through those 4 points, and it needs to be circular, not diamond shape. Now, we haven't talked about the equation of a circle yet, so it just says describe, I would say, a circle with center P and radius 4. Example 5, our last example says graph and state the equation or equations of the locus of points 4 units from y equals 3. Y equals 3 will be our given information. That is a horizontal line. It crosses the y-axis at 3. So draw that in as solid. Now I want to be 4 units away from that. There will be 2 parallel lines. One of them will be 4 units up from it. So 1, 2, 3, 4, right at the very top of this grid. And the other one will be 4 units down from the blue line. 1, 2, 3, 4. That'd be right here. So I just graphed those. Now I need to state their equations. If they're parallel to y equals 3, they'll be y equals something. The one on the bottom crosses the y-axis at -1, so that equation is y equals -1. The equation at the top, we have to count up from the x-axis. 1, 2, 3, 4, 5, 6, 7. That's y equals 7. There are the 2 equations. And that concludes Lesson 7-2.